this is Dave. Thanks for watching. Today we're going over a few recent presentations made by Rocket Lab's CEO Peter Beck and their CFO Adam Spice. They spoke separately at a couple conferences. Peter Beck was at a small sat conference and Adam Spice was at a investor conference, Canaccord Genuity, I believe. And usually when they speak at these things, I like to listen to the whole thing and kind of just cut out the bits that I find most important, most interesting, give my thoughts on them and share them with you. That way, if you're busy, you don't have to sit through the whole hour-plus long presentation, and you can just fast forward to the good bits here. But before we get into that, please hit like and subscribe down below to help out the channel. I'm really hoping to hit 1,000 subscribers before the end of the year, and every subscriber is very much appreciated. So with that, let's dive over to the presentations. Okay guys, so first up we're going to listen to CFO Adam Spice talk at a recent Canaccord Genuity conference for investors. I actually found this one extremely interesting. There's a lot of details that I found very valuable, so let's dive into the most important bits.
From a state-of-the-art manufacturing perspective, we have, again, a broad footprint. We have the capacity right now to build up to 1 Electron per week. We're in the process of, we're launching approximately 1 per month. Our goal is to roughly triple that over our current planning horizon through 2027. But really we achieve our target model for Electron when we are launching twice a month. So we're about halfway to our target model for launch rate for Electron, which is our small dedicated launch vehicle. And again, we have a lot of capacity to scale up. And similarly, we have a lot of capacity also for our space systems business that's ramping pretty aggressively.
So a few things about this statement. First of all, it kind of touches on one of the bigger concerns around Rocket Lab, which is that they now apparently have the capacity to build a rocket a week, and they're only launching about 1 a month. So the issue, usually you see companies being supply constrained, but in this case, they're really demand constrained, at least in terms of customers being ready. The counterpoint to that is that the backlog is growing rapidly. It's just that for whatever reason, the customers don't seem to be ready right now. So it's a little unfortunate, but it does seem like the demand is growing and we're going to see more and more launches in the future. They see us scaling up to 3 times a month in 2027, at which point launch will be a very profitable business.
So a little bit more details on the launch side, kind of mention the infrastructure that we have, which is incredibly strategic. We really view launch as a strategic enabler for our broader end-to-end solutions business. We're of the view that you can't just be a satellite manufacturer or even a constellation operator. You really need to have launch as that strategic kind of moat around your business, because when you have that in your toolkit, you have a lot more options to optimize around.
This one I found interesting just because even though launch is not really the driver of revenue right now, it can still be extremely important in that it's very strategic. It's really the hardest thing to solve if you're competing against another satellite manufacturer who doesn't have launch and isn't able to offer that. That gives you a big advantage over them because they're going to have to try and find someone else to launch it and pay extra money for that. If you can offer it all in-house, it's really more streamlined, more easy to manage, and really gives you an advantage over those other pure play satellite manufacturers and operators. So even though launch is not really bringing in the money right now, and in fact it's losing money right now, it's still an extremely valuable asset in that not a lot of other people can do it, and it allows you to bring your other products and services to a much wider audience.
We feel like we've covered probably 98% of the I would say the development side to make sure that we can actually accomplish this. So you'll see some announcements coming not too long distant future about recovery operations and hopefully bringing the stage completely back to the launch pad, which will be a huge proof point for us.
So not a ton of new stuff there, just talking about the reusability and how they're very close to being able to reuse an Electron. So he's saying they're about 98% of the way there from a development point of view. That's comforting to hear. I'm sure we're going to see rocket caught and brought back very soon. Unfortunately, this previous one just yesterday, I don't think the launch profile allowed for it. It was going to sun synchronous orbit as opposed to just low Earth orbit, so probably a lot more heat to deal with and more difficult to bring it back in that scenario.
Again, I think where we look at it, we see that we're enabling the entire space economy. We see providing soup to nuts solutions being incredibly important. When we see ourselves competing against folks that are much more siloed, we see ourselves really stacking up well. And probably the best example of that, I'll move forward, is this contract that was announced last quarter, which was the win of a MDA Globalstar contract to build 17 satellites. These are pretty sophisticated satellites. We're not talking about CubeSats. We're talking about 500 kg satellites that have extensive capabilities and will be operating in pretty hostile environments from a radiation perspective and have pretty healthy life expectancies on orbit. So these were very complex satellites, and we outmaneuvered a lot of established tier ones and established primes in winning this contract. So we surprised a lot of people with this. And this is further helping cement our capabilities in the space and really also providing that pathway for us to have our own capabilities ultimately to have applications of our own on orbit. So by building spacecraft like this, we can really build anything for anybody, including our own needs, as and when we identify the right last end market application.
There's a lot there in just a minute or two of Adam talking. Yeah, there hasn't been enough attention put on this MDA contract for the 17 satellites manufactured. I feel it really vaults Rocket Lab up into the tier of the prime satellite manufacturers and contractors, where it's a very select group. Not a lot of people can do this, and now they are able to. They're building out a whole new facility to complete this contract, and that facility will be able to be used for future larger satellites going forward. And also, it's just extremely exciting to hear him talk about potentially owning and operating their own space assets going forward, because that's what really gets me excited with this company down the line, is potentially operating their own satellite constellations as a service.
And lastly, on the space application side, it's really all about tapping that largest part of the market. So as I mentioned before, approximately 90% of the overall TAM is represented by the applications and data provided from space. So right now, again, we're very much focused on providing the picks and shovels to the miners, but we're also actively looking at if there are potential mines out there that we want to own ourselves. But it's first about creating the capabilities and really kind of working with our strategic customers, provide them end-to-end solutions that enable their existing business models.
So that's the exciting stuff I'd like to hear about, is them potentially owning their own quote-unquote mines or space assets, space constellations in the future. I'm really curious, what do you think they'll end up going for in terms of owning and operating their own constellation? Do you think they're really willing to compete head-to-head with Starlink and SpaceX in the internet satellite business, or would they shoot for something different, perhaps imaging, perhaps radio, weather, visual? There's a lot of different applications out there that they could go for. So let me know if you have any ideas down in the comments what you think they might be interested in.
Yeah, so the way that we look at the capability of providing end-to-end solutions, there's a lot of elements of a mission that end up being bottlenecks. So for example, if you want to typically order reaction wheels, you have to get in line. It takes a year to get reaction wheels. It takes a year or more to get solar solutions. So by having them all together under one roof, we can prioritize our missions as well as continue to service the merchant market. And you can continue to get different flavors of like, for example, radios or attitude direction control systems and different elements of the subsystems. But what we're really trying to do here is be able to go to a customer and basically say, look, we can handle it. Ultimately, what do you want, right? So what we're trying to enable here is both for the customer's benefit and ours, to say, look, let's make life as simple on you. What you really want is your data. Tell us what your data needs to look like, and we'll build a solution to get you there. So ultimately, what that enables for us is, by having all those pieces, we can provide schedule certainty, performance, and cost advantages, but also get to a point where we can start generating recurring revenue, because in certain situations, we may actually own those assets. Right? We may own those assets on orbit and just provide the data to the customer. And hopefully maybe those assets on orbit are multi-purpose, so you can have multiple customers leveraging that same space-based infrastructure. So for us, it's, again, we want to get to the point where we move more and more away from kind of event-driven revenue to much more kind of recurring based. And the space systems is a great way of doing that, because launch is very lumpy, right? Launches can get pushed from one quarter to the next, customers can be delayed. But the space systems business is much more programmatic, where you have programs that last for multiple years, and you get to bill against milestones and so forth. It's a much more predictable, stable, steady business, and so we want to grow more of that. And the ultimate stable part of that is if you actually recurring revenue based on a services model. So that's really what it's all about. We want to have all the technologies under roof to be able to do that and not have reliance on third parties as much as possible.
Probably not a ton I need to add there. I think Adam really covered it well himself, but just summarize, we're going over a lot of the benefits of the vertical integration that they've previously acquired all these various companies to be able to offer, and now talking about the future, potentially owning and operating their own satellites in orbit, which will allow a very regular recurring stream of revenue that Wall Street absolutely loves instead of the lumpiness from launch.
Payloads are very unique in the fact that payloads are very specific, and that's something where we could maybe acquire more capabilities for providing the payloads versus the satellite bus itself, which think of that as a chassis. And then you could always add more capabilities as far as owning more of your ground station network versus having, we have partnerships in place with KSAT, for example, which has one of the largest, ground station networks. But theoretically, you could vertically integrate more around that as well. So that's the great thing about this business. Is if we want to, there's a lot of depth that we can pursue. We can add a lot to the business.
Okay, so that was the end of the clip. That question, the last one, was on what they might potentially look for in terms of future acquisitions. They've already done 4 or so in the last couple of years, and he kind of flagged payload as a potentially interesting area. So right now they have the satellite bus and all that sort of thing pretty much covered off it very well, as well as the solar panels, reaction wheels, star trackers, and flight software. But there's a lot of variability in terms of payload, so potentially we could see some kind of acquisition on that front down the line. And the manufacturing of payloads and satellites is actually where a lot more of the money is made. So interesting to hear about that, and glad to hear that there's a lot more depth to the industry that they can potentially pursue. So that's the end of Adam's presentation. Now let's hop over to what Peter had to say at a recent SmallSat conference. Okay, so while Adam there was talking to basically potential investors, so he's talking about a lot of the financials and what things can make the most money. This presentation is really to fellow peers in the industry in the small sat space, so it's probably going to get a lot more technical and a lot more details about their various spacecraft and their rockets, but I still think there's some valuable stuff to glean from this. So let's take a listen to Peter Beck at his keynote on this conference.
So what ultimately we ended up here is a launch site that's capable of launching every 72 hours. We're licensed to launch every 72 hours. But probably the biggest learning from all of this was our assumption that we're going to have a dedicated service, so flexibility is going to be needed. It really pays off, because if we poke our head out one morning and we don't like the look of the weather, we'll just roll it back in and not launch that day. Or likewise, if a customer has an issue with their spacecraft, they need an extra day or 2 to resolve, no big deal, we'll just roll out when the customer's ready. And that becomes very challenging at traditional launch sites where you're scheduled and you have very short time frames to get your launch away. So that vision of what we wanted to create there has been super important and really valuable.
So just talking about the launch sites there, which I don't think get enough attention, because really the launch site in New Zealand is extremely valuable, and a lot of people I think don't realize it. They can launch about 170 days out of the year because it's their own launch site off in a peninsula in New Zealand, where a lot of these other launch sites in the United States are shared, and you have lots of scheduling conflicts. So being able to be responsive, change around the launch dates is extremely important. I remember there was a story a while back, I believe it was a Delta 5 or something like that, was having trouble sitting at a launch pad, and because it was having trouble getting off the ground, and they had to delay launches for all these other rockets as well. I think there was a Falcon 9 that had to be delayed and a bunch of others. So having Rocket Lab off in New Zealand on their own, owning their own pad completely, offers just a ton of flexibility for their customers.
So now we have a total of 3 pads and 2 hemispheres. So in saying all that, we built a pad at Wallops Island, and NASA assure me that the AFTS system will be complete this year for a December launch. So we're really excited about that. In fact, this month the launch vehicle will be shipping there. We've already had a launch vehicle there and wet dressed it and ready to fly. We put that launch vehicle back into circulation and shipped a new one there. So we're all hanging out for this launch out of Wallops at the end of the year. And that launch site was really designed around one express purpose, and that was responsive access to space. So what everybody sees there is like a launch pad. What you don't see is a whole ICF facility that's just back from that, where we're able to process 3 electrons. We have clean rooms, hazardous fueling operations and facilities there. Skiffs, everything, you name it, that's designed for rapid call-up. So, responsive space is obviously a big topic. It's something that we're very passionate about, and we built this launch site for that express purpose, where right from call-up to the pad to launch is capable of doing it in what you would generally measure in hours instead of days. So that launch site, we're really excited to fly out of the first time and provide that national capability for all of our customers.
So I don't believe he gave this news anywhere else before this, but if you're not aware, Rocket Lab's been basically ready to launch at their new Wallops United States launch pad, and they've been waiting on NASA to certify some software. I believe it's flight termination software, not positive on the exact type of software, but anyway, they've been waiting for ages on NASA to certify this, and apparently now they have assured him they will certify by December, so they'll finally be able to have their first launch from North America, which is nice in terms of being able to launch responsively for customers. They don't have to ship their stuff all the way out to New Zealand if it's an American customer. These responsive launches, they are able to charge a premium because they're being so flexible and allowing customers to get to orbit so quickly. So enabling that in the Northern Hemisphere is helpful as well, and just for fans like me who like to watch the launches, it certainly helps to have one a little bit in a little bit of a better time zone.
So we're sort of bouncing around a bit, but no good rocket is any good unless you've got a good engine. We named the Rutherford Engine after Ernest Rutherford. Ernest Rutherford was an incredible physicist. In fact, all of our engines are named after physicists. But he had a saying that I really loved, and it's kind of embodied the whole Electron program. And that was, his saying was, we have no money, so we have to think. And you have to understand that the development of the Electron program compared to rocket development programs or privately funded rocket development programs of today, we did that whole thing for tens of millions of dollars. That whole program. So it wasn't hundreds, and that's sort of become the standard today. We really built Electron and everything on the smell of an oily rag. So that statement really embodied what we were trying to do there. So
I thought this was interesting in terms of what it might mean for the Neutron development, because Rocket Lab really did develop Electron extremely cheaply at a time when there wasn't a lot of interest in investing in space. Over the past, I would say 5 years plus, there's been a lot more money thrown at the space industry. You have all sorts of startups like Astra or Relativity has raised $1.3 billion to fund their rocket ambitions, absolutely massive amounts of money. And Rocket Lab has really been able to do it on a very cheap budget. So I think this bodes well for Neutron's development, and they'll be able to create this rocket on the cheap as well.
And composites get a tough time about being really expensive and costly to produce. But the reality is, when you only have 1.8 millimeter wall, there's just not that much material in there. And we've developed and pioneered some really great mass manufacturing techniques. A first stage tube is literally tape wound. And then goes up into this machine you can see in this image here called Rosie, where all of the machining processes are done to it, and then you slide a couple of bulkheads and tubes and just glue it all together. So very, very low cost in the end, and super high performance structures. Electron is around about a 90% mass fraction complete vehicle, so really, really high mass fraction. And that's really enabled by all of the composite structures that are throughout the launch vehicle.
So composites have gotten a bit of a bad rap lately. A lot of the industry seems to be moving away from them. You've got SpaceX with their Starship going for stainless steel. Relativity, I believe, is also 3D printing with metal. It might be aluminum, but I'm not positive on that. So composites are kind of falling out of fashion, but Peter Beck is really fond of them, and they are extremely strong. They can be difficult and a little bit more expensive to manufacture, but I think on a reusable vehicle, I'm completely fine with that, right? Like, we're talking a 1.3 millimeter wide tube, so it's not that much material to make, and they have some great manufacturing processes around it. So I'm coming around to composites. I'm fine with them using it. It's very strong material, very durable and powerful, and obviously that's what they'll be using in the Neutron rocket.
So it was a perfect flight, perfect liftoff, perfect first stage burn, and great separation, second stage burn, fairing separation, and we were just sort of trucking on home to orbit. 90 seconds, I think it was about 90 seconds of ever want to hear a vehicle terminate, and of course we're all standing there thinking, well, it's right down the IRP. It's bang on trajectory. Why would we terminate? And this is kind of a tough lesson that we all learn in the launch vehicle industry. Those dishes on the ground were the flight termination dishes, and you may have seen them kind of wandering around looking for a signal. Well, the reality is there was one tick box in a piece of software that wasn't ticked for error checking, and as the errors accumulated, it continued to search around for the rocket and couldn't find it, and then ultimately was terminated. So I actually I took a screenshot of that software page and that tick box and framed it, and it's sitting in the entry of Rocket Lab. As a reminder to everybody, just how tiny the error can be, has to be before you lose the lot. But otherwise, what would have been a completely successful flight, we presumed to orbit. The vehicle was completely nominal.
So I mostly included that because I think it's a pretty cool story. That was their first ever launch. Can you imagine being the guy that was supposed to check off that checkbox in their flight software and didn't, and it resulted in the rocket terminating even though everything was going completely fine, and then an $8 million rocket just blows itself up? Crazy stuff, but it just goes to show how small a problem can be that can cause the loss of the entire rocket, and how delicate and difficult launch is. And Rocket Lab seems like they've really got it down at this point. It's a very strategic asset, as Adam Spice said in our previous video.
But what I will say is, just when you think you've got it all sorted and everything's going well, you get a baseball bat to the face. And we got to flight 13 before we had our first failure. I think it's, I was always told that flight 1 would fail, flight 3 would fail, and flight 10 would fail. That's kind of the general rule of thumb. We got to flight 13. And the tiniest thing, and what kind of like flight 1, it really does take the smallest thing in this industry, to have a really bad day. And you know, I always tell customers, and especially government customers, that, you know, there is nobody on this planet that wants to fail less than us. You know, mission assurance is a huge deal here at Rocket Lab, and you know, it's really hard to, you know, to explain how you know, how devastating a launch failure is, not just for the customer, of course, and not just for the company, but for the team. You know, after Flight 13, you know, everybody was walking around here like it was a morgue. But you know, we certainly didn't waste any time, you know, going to fix it. But you know, on Flight 13, you know, there was a high voltage connection that wasn't quite perfect. It passed all of the load testing and everything. But as the rocket was flying, you know, the connection heated up. And it's the most ridiculously unlikely set of events. You know, the connection heated up, the potting compound around the joint melted and liquefied, flowed in around the actual joint to then isolate the joint. Then the joint cooled, and as the copper bar cooled, it pulled across and recontacted and sent a giant electrical spike, and that was the end of that. So, you know, if you think of all of the improbabilities of those things happening, it really is, you know, a very difficult thing, and like I say, a baseball bat to the face.
Mm-hmm. Yeah, what a series of unfortunate events there. I think it really just, again, goes to show that the moat Rocket Lab has in the small sat launch industry is bigger than you might think. Even if you get that first launch successful, you may have future problems. And just talking about how devastating it was for the failure to happen, it actually made me feel quite bad for Astra's team of engineers and people working there, because, you know, they had some major failures, really putting the whole company in jeopardy, and they ended up retiring that rocket. So I'm sure that would be extremely disappointing to all the people who worked on that rocket. I know they're just employees trying to do the best they can and giving it their all, even if you may like Rocket Lab better as a company. They're still people too, just trying to work hard and be successful. So yeah, really feel for other companies that have had these struggles. They get the baseball bat to the face, as Peter said, and we've already gone through it, luckily.
Electron was originally designed to lift 150 kgs to its sun-synchronous orbit. We're able to improve that and get that to 200 kgs. This flight lifted 320 kgs to low Earth orbit. So it's fair to say that you know, Electron can lift 300 kgs, no problems at all, but that extra 20 kgs really tough. And you know, this was the highest performing Electron ever. You know, the engines were at 110% the whole time, and you know, that vehicle really did. You know, we pushed that vehicle as hard as we could.
I was curious about this because in the manual for the Electron, it shows the capability as being 300 kilograms to low Earth orbit, and this recent mission for NASA, the Capstone mission, was 320. So I was wondering if they're going to up, showing that they're now capable of doing 320, but it sounds like that's really pushing the rocket to its limit. It's nice to see that the Rutherford engine can handle it, that the structure of the rocket can handle it, and it seems to me at least like they basically can do 320 now if they need to. You know, it won't happen all the time, but getting that extra performance out of the rocket is always useful.
Lunar Photon now is kind of stooging out there in our solar system, so it's around about 1.3 million kilometres away from Earth. It's on a free kind of return trajectory past Earth here later this month, and as it scoots past Earth, we've still got about 10 to 15% residual propellant in there. We'll have a crack at doing something cool with it and see how far we can get into our solar system. So a spacecraft, you know, as of today is happy and healthy. It was only ever designed for 8 days, but like I say, we're using this opportunity to you know, to learn what it's going to take, you know, to get to Venus and other far off destinations.
Okay, so that was the last clip there. That was obviously the Lunar Photon that dropped off the Capstone spacecraft at the moon. I actually, before this, didn't even realize it was going to be coming back towards Earth. It's kind of looping around. Orbital mechanics can be a bit weird that way. So it still has about 15% fuel, and it's going to do a burn as it passes by Earth to try and send itself into the deep solar system. Really interesting to see just how far it can go, how far they can push that little spacecraft. It's already outperformed what it was designed for, and sounds like they can do some fun stuff with it. I'm going to be following that one closely for sure. So that was it from Peter Beck and from Adam. Let's do a quick wrap up here of what we learned today. So that's all I have for you today. I hope you enjoyed those videos, learned something new about the company, and maybe saved yourself some time as opposed to watching the whole thing. Although if you do want to watch them, they are definitely worth a listen. I always find them very interesting. Hope you like the shirt, by the way. Brand new. I think it looks pretty cool. I like it. We have a Discord link down in the description below if you're interested in joining our Discord server where we hang out and talk stocks. See you guys next time. Bye.